Thank you. Thank you all for coming. Just before we start, we'd just like to let you know that as highly skilled as we are and adept at managing projects, this is only the first day we've ever spoke publicly. So please bear with us. Right, so it's about heritage carpentry and joinery in practice. So we've got an agenda there. So first off, we're going to do an introduction to myself, to Hayden, what Swifts are about. Then we're going to move on to the historical and architectural significance, conservation philosophy and standards, scope of carpentry and joinery works that we're actually carrying out on the town hall, the materials and techniques we're using, and then we've provided 3 case studies. We've got 3 lots of work. We've got lot 1, which is timber doors. We've got lot 4, which is perimeter panelling and boxing, and we've got another lot 2, which is like floor works. So we've got a case study from each section, which we're going to go through in a lot more detail for you. After that, we're going to go through the challenges of working with heritage, lessons that we've learned, and then a conclusion. Right, so introduction. We are part of the team delivering the Grade 1 Heritage Carpentry and Joinery restoration here at Manchester Town Hall, one of the most ambitious conservation projects in the UK today. Today we want to take you through who are Swift Crafted and how they got involved in the project, who I am and how I ended up here, introduce Hayden so that he can explain his role on the project, the heritage significance of this building, the philosophy and standards guiding our work, specific carpentry and joinery interventions, techniques, materials and craftsmanship, challenges encountered, and then lessons learned and future recommendations. Right, so who I am. As you see, I'm Paul Smith, the Operations Director of Swift Crafted. In May 1979, at the age of 16, I began my apprenticeship as a cabinet maker and joiner with a shop fitting company in Hertfordshire. My apprenticeship lasted 5 years and included 3 years of day release at college, during which I achieved my City and Guilds qualification. After completing my apprenticeship, I moved to another shop fitting company to expand my experience working as an on-site shop fitter on projects throughout the UK. During this period, I worked on a wide variety of installations, including department stores, retail shops, restaurants, hotels, and many other commercial environments. After 5 years on the tools, I chose to move into site management and accepted a position as a site foreman with a shop fitting company in Essex. Over the next 18 years, I progressed steadily through the organisation, eventually becoming senior project manager. My intention was to remain with this company long term, but the recession forced the business to close. Following this, I established my own joinery company, which I ran successfully for 4 years. However, running a small business meant installing work during the day while spending my evenings preparing tenders, managing staff and chasing payments, all while raising a young family. After taking stock of this period, I realised that my true satisfaction came from working on site and delivering high quality workmanship, rather than managing the wider pressures of running a company. In September 2007, I made the decision to close my business and I joined Swift Southern, who I'm with now, as a pre-construction manager. In 2009, the managing director asked me to take on the role of operations manager, overseeing all on-site activities. 2 years after that, I was invited to become operations director, a position that I accepted and I continue into this day. That's me. Then go into a little bit about what Swift Crafted is about. So, Swift Crafted is a leading UK carpentry, joinery and fit-out contractor with a heritage dating back to 1987. Originally founded as Swift Southern Limited, the company rebranded to Swift Crafted in 2013 to better reflect its specialist craftsmanship and expanded service offering. Over its 39-year history, Swift has grown from a small carpentry subcontractor into a trusted delivery partner for major commercial, residential, public sector and specialist projects. The business headquarters are based in Epsom, Surrey, and we operate across the UK, providing an end-to-end service from early planning through to final installation. The sectors that we specialise in, we've got basic carpentry and joinery, first and second fix carpentry, bespoke joinery and FF&E, supply and install, fit-out services, heritage specialist works. Swift Crafted has delivered projects across the following sectors. So we worked in government buildings, residential and commercial developments, hospitals and healthcare facilities, retail and shopping centres, education buildings, airports and public buildings. Our largest contract award to date was a prestigious Knightsbridge project, which was valued at 7.5 million. Swift Crafted is proud of its reputation in the following areas: quality workmanship, craftsmanship. We're all very proud of that, everyone that works within the company. Reliability, on-time project delivery, transparent budgeting and cost control, strong client relationships, and skilled personnel and long-term talent development. The company supports projects from early cost planning through detailed tendering, buildability reviews, CAD, BIM coordination and final delivery. Sorry, page stuck. Swift currently employ just over 40 people directly, including experienced tradespeople, project managers and commercial managers. The company generates approximately £8 million annual turnover. Swift continues to expand its capabilities, invest in apprenticeships and strengthen long-term client relationships. The company remains committed to delivering high quality, technically robust and beautifully crafted results across every project. Next slide. And then we just thought, just for the fun of it, we'd attach a photo. This is the Royal Opera House in Covent Garden. We fitted out the Limbury Theatre, which that is, and all of the ancillary areas, reception areas, bar areas. And that particular theatre, everything was American black walnut, walls, ceiling, floors, balconies, everything. And we manufactured and installed all of it, which we're very, very proud of even to this day. That's me. Right, so I'm going to hand you over to Hayden now.
Hiya, I'm Hayden. I'm the project manager for Swiss Works on the Our Town Hall project. I started my career in carpentry by completing a level 3 carpentry degree whilst working for a builder in the private sector. Then joined Swift Crafted in 2018 as a trainee quantity surveyor. Unfortunately, the QS route didn't really work out for me, but Swift Crafted appreciated my technical and practical knowledge gained through my time working as a carpenter and offered me the opportunity to work as a manager. And that's the role I've been in ever since. So this project here is the first project that or the first main big project I worked for with Swift. It's the old Smithfield Market annex to the new Museum of London location. So the old Smithfield Market, originally built between 1886 and 1899, will become the new home for the Museum of London. The annex building, previously the Fish Market, is being restored as part of this regeneration development. The project required an extended pre-construction phase to complete extensive surveys. Working with the principal engineers, we compiled dimensional and condition surveys based on the extent of timber rot to produce structural connection and repair details. To retain as much of the existing timber as possible, every rafter had different lengths of repairs. These repairs were carried out using a splice connection, bolts and double-sided tooth plate connectors attached to new C24 timbers to cut back the existing rafter. Our scope of works there were roof strip out, heritage timber roof structure, timber floor structure, slate roofing, lead gutters, bespoke steel gutters, liquid applied roofing systems, structural steelwork, decorations and engineering design. And we've got a short time-lapse video for you showing the extent of our works on that project. hand you back over to Paul.
Right, so we detached this photo. This was after we'd just installed the timber floor into the Great Hall. We just protected it, and we got the team together and just did a team photo of the team that was on site at that point of time. So they're all the people that are working for Swift on this project. Right, historical and architectural significance. Manchester Town Hall, completed in 1877, is a Grade 1 listed Victorian Gothic masterpiece by Alfred Waterhouse. The interiors include extensive solid softwood and hardwood joinery, handcrafted panelling, ornate doors and architraves, structural roof timbers and decorative carvings. Much of the original fabric has survived, which is both a privilege to work with and a conservation challenge. The heritage priority preserve as much original timber as possible while ensuring long-term performance and public safety. Right, conservation philosophy and standards. Our work follows BS 7913 2013, Guide to the Conservation of Historic Buildings. The Grade 1 philosophy, repair rather than replace, minimum intervention, honesty of repair, reversibility where possible, and documentation of all interventions. Emphasise stewardship and extending the life of assets. Each intervention is assessed through conditional surveys, heritage impact analysis, material compatibility tests, and approval with conservation officers and architects. Next one, mate. Right, so our scope actually on the town hall is divided into 3 lots. The lot 1 was door repairs, fire grades up, ironmongery. So under lot 1 works, we're contracted to do door repairs, door relocation, door removal and fire door upgrades. Restoration of existing doors, retaining the original hinges, handles where possible. Reproduction of missing period mouldings, panels, ironmongery where applicable. Removal of existing finishes and dealing with risks associated with lead-based paints. Refinishing of all existing and new matching repairs using materials to achieve a finish which matches the existing environment. Improving existing fire-rated doors by installing new fire-rated panels, fire-rated glazing, new timber beadings and new intermittent strips while maintaining the existing door and frame appearance. Installation of refurbished and new ironmongery matching existing where required and providing access control to certain door sets throughout the project. We're also contracted to do some automation to some doors. The next lot of work we've got is the VHS rooms, which is very high significance rooms, Great Hall flooring and Great Hall panelling. So under that lot, we've had VHS and Great Hall floor boxes. We've had to form new floor boxes for the services beneath it, floor access hatches and floor trenches, all to get the new services in, obviously to upgrade the building to make it more modern. The very high significant floor lifting, reinstatement and repairs. The Great Hall wall panelling alterations. Great Hall new oak timber flooring. And then we've got the builders work in connection with mechanical and electrical services for access, to get them access through the floors before the timber floors go down. And then an item that was added to our contract was the ceiling boss replacement, which we're going to go through as one of our case studies. And then last but not least, the lot 4 package that we had was for perimeter boxings and cabinetry, including repairs. So we've got cabinetry, panelling and perimeter boxing adaptations and alterations. VHS repairs, window seats, radiator casings and associated frameworks. Next one, mate. Materials and techniques. The timber selection, the species were to be matched exactly where feasible. So the existing timbers are English oak, Douglas fir, pitch pine, and sapele. Sapele's not on the project, but we've had to use sapele for our FD30 repairs to the softwood doors because softwood can't meet the rating for 30-minute fire rating. All the timber that we're bringing in has got to be temperature controlled, moisture controlled content to match the existing on-site timber, because some of the timber's been here for 100, 150 years, and the timber we bring in, when we're applying it to the same door that's got old timber, we have to make sure it's the moisture contents all balance up. Traditional techniques, we've got hand-cut joints, mortise and tenon, scarf joints, bridle joints. We've also got some hand carving, which we're going to go through when we come to the ceiling bosses. Mixed with the traditional techniques, we've obviously got modern techniques, use sensitivity. We've got hidden stainless steel strengthening where required. We've got low visibility resin repairs, laser scanning for accurate replication, and CNC machining for rough shaping, followed by hand finishing in workshops and on site. Right, so the case studies, we've got a restoration of a typical door set for lot 1. Lot 2, we've got room 202, 203, perimeter boxing, and then lot 2, we've got the ceiling bosses. So I'm going to hand you over to Hayden. Yeah, mate.
So, like Paul said, we're going to start with lot 1, which is the restoration of a typical door set. So the first stage of the refurbishment of the doors is stage 1. So this can best be summarised as identification, removal, and stripping of existing finishes. So, first step is identification. There are 3 types of doors in the Our Town Hall project: retain, move, keep. Retained doors are those that are staying in their original locations. Move and keep doors are basically one and the same. A keep or a K door is one that's either down to be removed to storage or kept for use elsewhere in the building. A move door, or M door, is the reference of the new location of a door that's been kept for storage. Bit confusing, but we've somehow got our heads around it by now. In this instance, O2 CO2 DO1 is what is known as an M door, and that has been moved from O2 CO2 DO5, which is a keep door. Once the door is identified, we catalogue the door in its current configuration, taking pictures of the condition of the door and its ironmongery, as you can see on the slide here. Then the ironmongery is removed from the door and catalogued separately. So ironmongery items such as the hinges and handles are sent off to our specialist ironmongery supplier for refurbishment so that they can be retained and used elsewhere in the building. The rest of the ironmongery is offered up to the Manchester City Council, and then from there they can decide which items they want to retain and which items they don't. The door is then sent to our stripping workshop where the original finish of the door is removed. Be it paint or shellac, we use the same water-based paint and varnish stripper. The reason we need to remove the existing finish from the door is to first allow us to identify any additional or hidden repairs, as finishes, especially paint, can hide some damage that's been done to the door. And secondly, we remove the finish because it will be much easier to completely reapply a new finish to the doors than it will be to try and blend in any repairs. We then identify some of the repairs just to make things easier for our carpenters on site. We just put a red dot next to them just so they know that's a repair, go ahead, do it. Stage 2. So during stage 2, there are 2 separate but concurrent goals that we are trying to achieve: restoration and fire door upgrades. So first we'll look at the restoration side. The goal is to restore and repair door leaves whilst being sympathetic to the history and heritage of the doors, emphasising stewardship. There's an art restoration style called rigatino. Definitely butchered that if you've ever heard of it. Wherein the retouching to a painting is applied in a way that the restoration is purposely visible so that you can identify the intervention. We have a similar goal in mind with our intervention to these doors. We use donor materials that come from the building to complete our repairs where possible to best match the existing, and where possible we make our best efforts to match the grain of the repairs on the door. So whilst each repair will be visible, each repair also tells a part of the history of the door. The restoration goal is split up into 19 general repairs, not all of which we will be touching on today, but we will be hitting the main ones. So these general repairs have been identified by the architectural team and instructed to us via the door repair schedule on the slide here. These capture about 90% of the most common repairs from door to door. So repair type 1 is a mortise lock cavity. These infills are arguably the most important repairs to be complete to a door. The mortise cavity is squared up using a chisel to accept a perfectly sized block of timber. For softwood, non-fire rated door, we would use a donor piece of Douglas fir that comes from the building. For fire rated softwood door, we would use a new piece of sapele timber, as this is a slower burn time than Douglas fir. For an oak door, we must use solid oak no matter whether it's a fire door or not. This is because sapele will leach tannins into the oak, staining it wherever it's located. So this repair also forms the base of the handle repairs, escutcheon, and digital lock repairs, because it forms a solid base, a solid backing to allow the patch piece of timber to be applied to. So the overhead closer hole repairs are quite a simple repair. Whatever repairs have been left over by the door closer mounts are drilled slightly larger than they are to accommodate a standard sized timber dowel. These are set in so that when they're cut flush to the door, the grain lines up with the existing grain. The lippings I'll expand on in a little bit because they go into the fire door upgrades as well. Fire door upgrades. So due to the building being a public but also a working space that will probably have between 600 to 1,000 people in it at any given time, there's not only a legal but a moral obligation to protect everyone who may be in the building. There are some high-risk locations which require new modern replicas of the existing doors which achieve FD60 rating. These are installed by others. We at Swift Crafted have been given the task of upgrading the existing heritage doors to achieve a FD30 fire rating. We achieve this using a number of methods designed by a fire consultancy firm called JQA, Jerry Quayle and Associates. Jerry Quayle himself having had a hand in advising on some of the British standards for fire doors that are still in legislation to this day. So safe to say they know what they're doing. Just a quick one. A word I'm going to be using a lot, which you may not have heard of before, is intumescent. So this refers to a material that, when exposed to extreme heat, expands and swells. So this works either to create a protective insulating barrier and or to seal gaps. So hinge pocket repairs. On non-fire-rated doors, as we're using original hinges to hang the doors, we've been asked not to repair them and maintain the heritage of the original install. However, for fire-rated doors, as we're using a smaller but stronger modern hinge, we must infill the old screw holes with the same method used on the door closer holes and glue in a patch which covers the extent of the original hinges. This is so the new hinges can be cut in tightly. The hinges are then installed on an intumescent pad, which you can see on the sort of bottom left picture there. Threshold drop seals are routed into the bottom of doors. They drop down once the door is closed to create a tight closed seal, preventing smoke coming through the bottom of the door. So if you remember the lippings I mentioned previously, the main reason they are used is to ensure that the door fits properly in the opening, as the doors and frames have been in situ for almost 150 years. They've had plenty of time to swell, shrink, and otherwise move. So adding lippings means that the doors fit the opening properly. With fire doors, we have to meet a door gap from leaf to frame of 3 millimeters with a plus or minus 1 mil tolerance. Research shows that this gap will provide the best smoke resistance while the door is still able to operate freely. Additionally, this size gap gives the intumescent strips we're going to look at in a second the best chance of working. The diagram here shows our process of measuring the fire gaps. So you measure around starting from A to H. And then these are some photos of that process in real life. So here is a intumescent strip, as mentioned previously. It's a little bit hard to see. Oh, sorry. It's a little bit hard to see, but this is a smoke and acoustic seal. The jargon term for this is often called a batwing seal. This is a second line of defense to stop smoke and flames should the intumescent strip not function properly. So the Palisol SW2 boards are probably the second most important fire upgrade to doors. All the timber in the doors have an approximate burn rate of around 1 millimetre per minute. So these doors being on average around 44 mil thick means they should have an inherent fire rating of approximately 44 minutes. But their weak point is the recessed panels in the doors. So these average about 12 mil thick, obviously, so only 12 minutes of burn time. So to increase the burn time of these panels, we have to apply Palisol, which is a intumescent sheet sandwiched between a thin layer of veneer on both sides. These sheets take about 20 minutes to burn through, thus bringing the total burn rate of the door to about a 30-minute threshold. These are glued in place using a fire-rated glue. They are then additionally held in place using hardwood timber beads, which are embedded into an intumescent mastic, creating a closed system which protects the weak point of the doors. Door rebates also have to be increased in depth to meet the current fire regulations. This is achieved by installing a new plant-on doorstop with a fire-rated glue and nailed in with pins. The most important part of the fire upgrading process is infilling the gap between the door and frame and the structural opening. This is because we're working with existing structural openings. When these doors were built, they probably didn't have a concept of a fire door or fire stopping, so the tolerances around doors are often up to and above 30 mil. We had to survey all the openings on site and report where frame to opening tolerances exceed 30 millimeters. At this point, one of the masonry contractors on site is instructed to go around and point in these spots with a fire cement mortar so that the remaining gap is 30 mil or below. Then we come in, fill the gaps less than 30 millimeters with a fire-rated expanding foam called Blue 60. We use an extension tube on the gun we use to do that to reach the back of the frame and backfill it to ensure that the whole void is filled. Any gaps less than 5 mil, so 0 to 5 millimeters, are infilled using a intumescent mastic only, and this only has to reach a depth of 10 millimeters. Following the fire and stopping, we need to install a 15 millimeter timber ground. This acts as the first line of defense burn layer for the fire stopping below, while also providing a solid ground for the architraves to be fixed to. So, as well as restoring the doors and frames on this project, we are also repairing and restoring the existing heritage architraves where possible and available. When installing the architraves, the first step we need to do is outer a rebate into the back of the architraves. This is because as part of the ongoing upgrades for the building in general and to the doors, the M&E contractor is installing a lot of electronic fixtures and locks to the doors. These range from Wi-Fi points, fire escape signs, automated door locks with contactless access. Then we need to take because of this, we need to take the existing architraves, recut the miters at an exact 45-degree angle. Then we use something called a biscuit cutting tool, which carves a biscuit joint for a biscuit, which is basically just a small bit of wood, which stops the miter from twisting. So this strengthens the joint and, hopefully prevents any further movement. The architraves are installed as one piece using ring nails that once driven into the timber resist pulling out because they have a backwards pointing ridge or ring. Hole repairs are carried out in much the same way as the previously reviewed door closer holes, and the solid fanlight upgrade is carried out in the same way as the previously reviewed palisol and beading installs. So addendum repairs are a discoverable repair that has a pre-agreed repair convention. In this case, or in the case of this door, we have 2 addendum repairs, allowance for up to 3 number lippings to all edges versus the allowance for 1 number on the main repair schedule. Also, an additional repair was identified. Also an additional digital lock repair was identified once we reviewed the door. An SRS or site record sheet. So these repairs are reportable repair anomalies that require architect intervention, i.e. discoverable repairs that have no existing repair conventions that can be applied to it. So these can range from anything such as a cracked door style, a solid panel that turns out to be plywood, or a twisted door. Speaking of which, this door had. So we found upon installing the door leaf into the frame that the top of the door was sitting about 15 mil proud. So this obviously needed to be repaired. We collaborated with the architect to come up with a solution, and the easiest solution we came up with was to cut the rebates of the frame back at an angle so that they follow the shape of the door. So although the bottom of the door would then sit in 15 mil too far, at least this meant all of our fire door seals are fully enclosed within the depth of the frame and were allowed to work as they're intended. So now we have some door samples to pass around if you want to have a look at them.
Right, a bit differently this time. So this is just the bare timber that's just been stripped, ready to receive the finishes. And if you can just pass that round, then you got it with the first sealer coat on it. Then you got it with the colour applied to it. And then you got it with the finished oil on the finish. All right, so at least you'll understand a bit more. When I band them out, I just handled them all out last time. Everyone's just looking at different bits of wood. While that's going round, we've got this was where Hayden was talking about a hinge repair. We had to they had a small hinge in there, so you had to router it out, fill the holes behind the pit timber, put a new piece of timber in there, and then the new hinge is fitted into there. And then this is the fire-rated panels. And this is one with just one colour stain on, and this is one with two colour stains. And the reason we've got two different colours is some doors are lighter in different areas, and some doors are slightly darker. So we're colour matching the doors to the rooms with the timber panelling that they're in. So there is some variance in colours. And that's it, this one, isn't it? That's it. And then it's just a sample of the beading for the palisade panels.
Right, while those are going around, I'm going to carry on. So, frame adaptations. So, this door is that one that, when it was moved from its location to another, it didn't retain its frame as the original frame was left in situ. So, we had to locate a suitable donor frame, which luckily we had one that was in storage. The only problem was that the frame was too tall and too wide. So, apart from that, it was perfect. So we carefully dismantled the frame piece by piece, inspected the components for any damages, and then repaired them using the same techniques discussed previously. Then we had to reassemble the frame. To do this, we basically just shortened the components where required, and then using traditional carpentry techniques, we replicated the original joints and put it back as original. So stage 4 is where we complete our first fix ironmongery installations. Hang on. This is where we do any machining and the test fit and application of all the ironmongery. This is then removed and moved back to storage to allow our polisher to come in and repair any minor scratches caused by the install. The polisher will lay on his initial layer of shellac and then his initial layer of stain, and this will protect the door, but also, as you can see in the photos, it highlights any differences in how the timber accepts stain. Using this information, he will adjust the colour mixture of any future applications to bring everything up to a single unified colour. I'll just skip over that. So, stage 5 is a final polish of the doors. So, by this point, you can see that the polisher has put in the work to bring the door up to a single unified colour. A coat of hard wax oil has then been applied to the door to give it a hard wearing finish with a medium sheen level so as not to look too new. The ironmongery has then had its second final fix, where it will stay and then be commissioned. So I hope you can appreciate how much work goes into restoring these doors, not only on the hands-on side of things, but also on the record-keeping side of things. If you've noticed, we have a picture of every single repair that we've completed to this door for this presentation. So for every repair undertaken, we have to take a before, a during, a during, a during, a during, and then an after. These are all uploaded to a QA system called Sublino to be able to sign off a door as complete. If you'll look at the slide, you'll notice that we have well over 100 pictures, and that's just for stage 2. and that does not include the other stages. On our server at the moment, I estimate we have probably between 35 to 40,000 photos of the repairs we've completed so far. And that's it for the doors. So if you'd like to watch this short time-lapse video, just shows some of the work being done to the doors in our workshop. Right, lot 4. So for lot 4 works in the Our Town project, they include the reinstatement and adaptation of heritage boxing and carpentry. So we have pretty much the same exact goals in mind when restoring these items as we had with the doors, this being restoration and stewardship. However, these works we're also having to adapt the existing panels and boxing into a new configuration so that they can cover up the new MEP encasements. So the first stage, pretty much the same as the doors, is to identify the panels required. A lot of these had previously been removed towards the beginning of the project, way before we come to site. So our first task was to locate everything, which sounds like an easy task, but these panels, for example, were found in a cage on a completely different floor to the one that was removed from. Once the materials are identified, then we need to assess them for any damages or any missing items that will then need to be replicated. We then offer up the existing panels to the MEP encasement and review and agree with the architect the final setting out. Any repairs may be required and any adaptations that may be needed to fit the panels. We have a small piece of panel here. It's a little bit big to hand out and pass around, but feel free to come up and look at it at the end of the presentation. So for the framework, on every other frame that we build for this lot, we are using traditional carpentry methods and joints to build the frames, including half-laps, dowels, mortises, blind mortises, and others. However, for this particular set of boxing in, due to the size constraints we've had to work with, we've had to incorporate our framework into the existing MEP Unistrut framework, creating a sort of hybrid of traditional joinery and mechanical fixings, such as bolting to the framework. For the repairs and installation stage, we first start with carrying out any minor repairs and adaptations as previously agreed with the architects. For this set of panelling, to fit everything at the correct height, we would have left a 25mm gap at the bottom of the skirting to the floor. So to accommodate for this, we had to extend the bottom of the skirting and the existing panels using donor oak sourced from the building. Some parts we install have to be completely new, as there would be no way to adapt the existing to work. So in this case, that was the worktops. For these, we had to create a template with a millimetre perfect scribe to the contours of the walls, because we have no back panels or corner beads which would hide any small deviations. These were then sent off to a joinery workshop that we've worked with closely for many years to create a worktop out of timber blockboard panels, which are then veneered on one side. And then for the finishes on the boxing, you'll notice that I haven't made any mention about the stripping process yet. That's because in this lot, there isn't any. For this lot, we only do minor corrective works to scratches and repairs, and all the rest of the new items are coloured corrected to match the colour and tone of the original panels. So you'll notice for this one, the colour is a lot more orange compared with the doors, but that's because that's what the original boxing looked like. Lot 2. So, as mentioned previously, our Lot 2 works cover a number of different items, but for this presentation, I'm going to concentrate on the ceiling bosses, their removal and repairs. So, in rooms 01005 and 01003, there are a couple of ceiling bosses which have been damaged over time or otherwise fallen apart at some point in the building's histories. This obviously needed to be replaced.
This is one of the broken ones.
These are the samples that go around. There are a couple of the actual ceiling bosses that we removed to replace.
That's another one there.
So for room 01005, this is a relatively simple task. We were able to remove one of the existing intact ceiling bosses. Our wood carver was then able to use this to turn a dimensionally correct bowl of sorts, which matches the dimensions of the existing ceiling boss. If you'll notice on the original ceiling boss, that picture on the left, the carving is very asymmetrical and imperfect. So if you look at the picture on the right of the one the carver made for us, he tried his best to capture that feeling of a perfectly imperfect replica of the existing. These were then handed over to our polisher, who had a similar end goal of replicating the imperfect finish, as the finish on the originals had degraded and worn over a 150-year period. So that middle photo is his first stage, and then on the left-hand stage, one of those ceiling bosses is the original. I don't know which one. I'd like you guys to have a guess which one as well. Yeah, so then once these were complete, they were then reinstated and screwed back into their original positions. So the ceiling boss in room 01003 was a very similar process. However, we had an additional challenge for this one, being that we couldn't actually remove the sample ceiling boss that we wanted to replicate. This is because, unlike the other ones which were screwed from the bottom and able to be removed, this one was screwed in from the top, and to remove it would require us to fully dismantle entire parts of the ceiling. This was deemed too excessive, as it would pose a risk to creating further damages to the rest of the ceiling. So, based on advice from our carver and through discussions with the architect, we decided that the best route forward would be to 3D scan the sample ceiling boss, take on-site dimensions, and then provide high-quality photos from multiple different angles. Using this, he was able to recreate another near-perfect replica of the original boss. So those two pictures at the bottom are of the one he created for us, created just from pictures and a 3D scan. I won't go into too much depth on this one, but we also have a short time-lapse video of the Lot 2 Great Hall flooring being installed. This has had its own set of challenges, ranging from agreeing appropriate fixings for the flooring as we're nailing new oak floorboards into heritage timber joists, agreeing setting out points for installations at the edge of the room that need to land within the width of a full board, and this is way before we ever knew where the boards were going to land at the edge of the room. So, all right, so tracking our progress. So, as you're aware, this project encompasses a wide range of work streams, each requiring the collection of significant photographic evidence and detailed data. Ensuring accurate and transparent progress tracking is essential, both for our internal management and for external reporting. To support this, we utilize several structured systems. Firstly, we use Sublono to produce electronic quality assurance sheets. These are accessible to all project members and provide a clear, real-time overview of progress. Through Sublono, we can monitor each stage of works from stage 1 through to full completion, record and assign blockers, when certain areas cannot be progressed, ensuring visibility and accountability. Maintain a robust audit trail for the Town Hall, allowing each element of work to be scrutinised for compliance and future-proofed for quality assurance. In addition to supply note, we maintain detailed internal progress trackers. The example shown above, or on the slide, relates to Lot 1. These trackers are colour-coded to ensure clarity and ease of use. Red identifies a blocker alongside a accompanying comment for context. Amber indicates that works are currently ongoing, and then green confirms that works have been fully completed. Given the scale of the project and the volume of information we must capture, these systems play a vital role in enabling us to manage and monitor and evidence progress effectively and consistently. Right, I'll hand you back to Paul. Thank you.
That's what you can say. You can keep that, that's all right. Thanks, mate. Right, challenges. Working in a grade 1 context, every component is potentially significant. Documentation required before, during and after intervention, as what Hayden's just been going through with the Sablono and our own tracking systems. There's as much work recording everything is actually carrying the work out. Access and logistics. We actually created workshops on site for the joinery repairs and stripping workshops as well, so that we could keep everything on site and keep control of it. So we're regulating all the finishes and everything to a certain standard, and we keep it more controlled like that. Limited removal of elements due to heritage constraints. Originally, there was some suggestion we'd be taking doors away to carry out all the stripping and everything, but it's a no-no taking that much heritage stuff away, so that's why we created the workshops. Utilising existing materials, donor doors. I believe we're probably up to about 90 doors in total for donor doors, which was used for carrying out repairs to the doors and frames. Another issue we've had is obviously historic timber is all to non-standard dimensions. Every new piece of timber we buy doesn't match the timber sizes that we had historically, so it's another thing we've had to get over when we're buying timber. And then we're moving on to craftsmanship shortages. There's a need, the need for advanced heritage carpenters and joiners can't be understated here. It's not just like putting a normal timber door set in. The skills that are required limits you to how many people you can actually get. And it also means that we've got 3 apprentices on this site, and it's difficult just to let them loose on work because obviously it's so critical. So this is a good example here. So basically what we do, we don't let them loose on anything until they can start making these so that they're fit and they don't fall out. So we start them on a half flat, then we start them on a tenon, then we start them on the splice, and then once they've done it properly and we're happy with it, then they move on to do it on the doors. So it is hard trying to keep apprentices going, especially the first year ones. Moving on to lessons learned. Early surveying is critical. Hidden issues are common. The amount of times, even with the door, it's a painted door set, it's got like 10 or 12 coats of paint on it. You can't see what repairs are required except the obvious ones. And then when you strip the door, all of a sudden it becomes apparent there's a great big split in it. You know, so there's loads of things that no one could have foreseen until it's stripped. So that does cause problems, especially with planning. Full collaboration with the design teams is absolutely critical. I mean, we've got experience with what we know, but with us and the design teams, you can come up with ways of working that works for the benefit of the project. Documentation, as Hayden touched on, is just as important as the craftsmanship itself, because obviously it's got to be, it's all historic works, it's got to be recorded, and the idea being that, you know, repeatability, the documented processes help ensure that each piece of repair installation meets the same high standard, and there's a proper record so anyone coming in 50 years' time will know exactly what was put on that door to polish it, what was put on that door to strip it, what material was used to repair it, all critical items. The mixing of modern and traditional methods where they must complement each other. In heritage work, people often frame modern and traditional methods as opposites. One rooted in history and craftsmanship, and the other in technology and efficiency. In reality, the best heritage outcomes come from allowing these two approaches to work together, filling the gaps that either one can't do on their own. And then heritage work requires patience. As you will all know, this has taken so much longer than it should have. But the building dictates the pace. There's only so much you can do. You can't rush this sort of work, unfortunately. Next one, mate. Right, so in conclusion, the Manchester Town Hall project is more than a restoration. It's a statement about protecting cultural identity through skilled craftsmanship. Heritage carpentry and joinery ensures that what was built in the 19th century remains alive for the 22nd. Thank you for listening.